Hello and welcome! In this lecture we're going to learn how to rotate our unit in order to face the move direction. Okay, so here we have our game so far. We have a unit and we can click anywhere to make the unit move towards the mouse. All of the animations are playing correctly, but as you can see the unit is not rotating to face the move position, so let's start that. Doing this is actually quite simple. Now there are several ways for handling rotation on a game object. One of them is to modify transform.rotation directly. If you're a fan of quaternions, then this is a great way to rotate. But for me, I always find quaternions to be quite tricky to understand, so I don't normally rotate anything this way. Another way is by modifying the transform.Euler angles. This one is a bit easier to understand. Euler angles are the kind of rotation that you're probably familiar with, so they go from 0 to 360 degrees. Alternatively, you can also use radians and do some math, so that's another option for rotating. However, something else that is even easier to understand, especially when dealing with vectors, is you can simply modify the transform.forward directly. You can set it to whatever you want the transform to point to. You can just calculate the move vector, apply it to this one, and it will automatically rotate the transform to face this direction. Personally, I find this one to be the easiest method, so let's use this one. Over here in our unit script, in this case, we're already handling the movement over here, so we calculate the move direction, so target position minus the current position, and we normalize that, so we already have the move direction. And over here inside this if, we already know that the character is moving, so this is actually super simple. Over here we can just set the transform.forward, and we just set it to this move direction. That's it, really that simple. Let's test. So here we are, and let's click over here on the right side, and yep, there you go, the character rotates perfectly. And of course the animations, all of them still work great, so everything is looking great. Now really the only issue that we see here is that rotation happens instantly, which makes it look a bit odd, so we can add some simple smoothing to improve the look of it. Over here, instead of setting the transform.forward directly to the target direction, one thing we can do is use vector3.lerp to add some easy smoothing. So this is vector3.lerp. You can see in documentation what this does, so it linearly interpolates between 2 points. For the parameters, it takes a starting vector, a final vector, and finally a time. Basically, if t over here is set as 0, then it's going to return vector a. If t is set to 1, then it returns vector b. And if it's any number between 0 and 1, then it returns the vector that is between a and b. So using this, we can really easily apply some smoothing. We just need to use our current forward as the start vector, so let's use transform.forward. Then for b, that is the final one we want, so let's use the move direction. And then finally for t, this one is time. Since this is going to be running on every single frame, then we can just use time.deltaTime. Basically with this line, every time that this code runs, it's going to get closer and closer to the move direction. Now here I should point out that the function is called lerp and returns a linear result. However, due to how we're using it here, we're actually going to have a sort of ease out instead of a linear motion. Meaning that instead of changing by the same amount on every single frame, it's going to change a lot in the beginning and then less and less as it reaches the target. The reason why it's not linear is simply because we're using a moving starting point. For the start value, we're using transform.forward, which is changing on every update. If we wanted this to be perfectly linear, then we would need to store the starting forward value and always use the same start and end while only modifying the time. But in this case, I think ease out looks much better than perfectly linear, so this is exactly the behavior that we want. I just wanted to point that out just so you're not confused with the function name and the behavior you see. So with this, it's going to smoothly rotate towards the target direction. However, like this, delta time is going to be too tiny, so it's going to be a bit too slow, but still, let's test. Okay, so here we are, and if I click, yep, there you go, it does rotate nice and smoothly. So it's no longer very jerky, very instant, it rotates nice and slowly. Now it's a bit way too slow, so let's speed it up by quite a bit. Let's do exactly what we did over here on the move speed, so let us not use magic numbers. Let's define just a float for the rotate speed.